Right. In the previous class, we started this protocol BGP. We learned very important difference between the IGP and EGP. IGP is only limited within an organization. EGP, the only EGP protocol is BGP. This works between borders. This works between autonomous systems. We saw why we need BGP. We saw different ways of learning routes from autonomous systems. And we also saw for what reason someone should go for BGP. At last, we saw this is a highly reliable routing protocol because it has got reliable communication method called TCP. TCP179 is the port number. I also said this is an application layer protocol. Updates are not periodic like RIP. It's incremental and trigger update like EI, GRP, and OSPF. We don't have hello packets here because this is TCP. You see, hello packets are sent to multicast address. Hello packets are sent to multicast address in order to discover neighbor. In BGP, there is no neighbor discovery. Neighbors are manually configured. So when you configure neighbors manually, to those neighbors, periodic keep alive. Keep alives are sent periodically. How often? Every 60 seconds. This is to make sure the neighbors still exist. And also to maintain neighborship. BGP has got attributes. Using this attributes, we can tune the path selection according to our policy. You see, BGP takes decision based on the attribute tuning that you do. That's the reason why you go for BGP. You have attributes to tune so that the path selection, outgoing, incoming, will be as per your policy. BGP, a protocol of internet. It is designed to scale huge internet work. Now this is a new page. We stopped in the previous page in the previous class. There are three types of tables. Neighbor table will have list of BGP neighbor configured and established. BGP table will have list of all the networks learned from every neighbor. And if there is multiple paths to destination, even those multiple, like a topology table. Not only that, for every prefixes learned, for every prefixes in this table, you will see attributes attached to them. Even if you don't tune attribute, there will be some default attributes there. Now, I want to add something here. It says list of all learned, network learned, not only learned, list of all learned as well as locally advertised. So BGP table is the place where you can see what you are advertising and what you are learning. Both advertising and learning. List of all networks that are learned from each neighbor as well as advertised. The routing table, as usual, will have only the best elective path. So three tables: neighbor table, BGP table, and the routing table. So I can say that there are two commands to see neighbor table. This command show IP BGP neighbor not many people use it. Not many people use this command. The reason is it's going to give a very big pages of information for each neighbor. So best is to use this command, show IP BGP summary. This command will show you all the neighbors in a summarized way in a small table. So use the command show IP BGP summary instead of show IP BGP neighbor. For what? For checking the status, whether the neighbor is properly configured, whether the neighbor is properly established, whether the neighbor has sent any update. This command is enough. Show IP BGP summary is enough to know the BGP neighbor status as well as the number of prefixes learned, all the stuff. But the command show IP BGP neighbor, when to use? Whenever you are trying to see something more about neighbor, like how many TTL, time to leave, the neighbor is sending a packet, or how many TTL you are sending the packet to the neighbor. What is TTL? Time to leave, meaning how many hops the packet sent and received will go, and things like that. Some exceptional. Okay. Now this BGP table is important. Neighbor table is important. In BGP table, you will see only those networks along with the attribute and the neighbor who has given you this, from which autonomous system it is learned, including the AS path, autonomous system path, etc. When I show you the output, you will see better things than me explaining. The routing table, as usual, you will have the best routes. message types. I'll be showing you all these message types in Wireshark. BGP defines the following message types. Open message. This is the very first packet after three-way handshake. Repeating again. BGP is a TCP-based protocol. So definitely the first thing that will happen is three-way handshake. Between two neighbors, first the three-way handshake will happen. On successful three-way handshake, the open message will be sent by both the routers to the neighbor. And all these are unicast. BGP is TCP protocol, so you cannot use multicast here. You can't send to someone. You should send to a particular IP because it's TCP based. So three-way handshake is possible only if it is unicast. Unicast. Keep alives are sent every now and then once the neighbor is established. That's every 60 seconds. But the open message is only in the beginning. Next is the update. Information for one path only. Could be multiple network. Includes path attribute and network. Very important. See, BGP is not the protocol that will send multiple path for load sharing. No. Whenever BGP sends update, it will send only one path for each destination. The reason is it won't use multiple paths. If it is not using multiple paths, it cannot advertise as an update. When it uses only one path, when BGP is not designed to support load balancing or use multiple paths, it can only send one path. So along with each prefix advertised, attributes also goes with the advertisement. That's an update. Next is notification message type. This comes into picture only when error is detected. All of a sudden a neighbor itself is broken. So notification will be sent whenever there is an error. All right. So we have come to the end of the first chapter. We learned what is multi-homing. Connecting to more than one autonomous system. Or in this example, we see here connecting to more than one ISP or more than one internet. That's multi-homing. That is the scenario where you will have policies. When policies are involved, BGP is the best protocol. So that forwarding decision can be based on the policy, not based on the best path. Nice word, the last line. Forwarding is based on policy, not based on best path. So far, whatever the routing protocol we have learned, those protocols were forwarding as per the best path. Best path, low cost path, less number of hops. BGP will not care about your best path. BGP will not care about bandwidth, delay. No. BGP will not care about these things. BGP will only focus on policy. BGP will not choose the best path according to the bandwidth or the hop counts. Right. Forwarding is based on policy, not on best path. BGP routers exchange reachability information called path vector. Yes. I showed you, it will show you the autonomous system path, the autonomous system via which the destination can be reached. It shows the complete path from next hop autonomous system to the last autonomous system where the destination is. Right? We also learned that there are three tables. Neighbor table has got neighbors. BGP table will be like a database where it maintains all the routes received from the neighbors as well as the local routes, connected routes, which BGP is handling along with attributes. And also we saw there is a routing table where the routes are kept. BGP will never do load balancing, so there is no concept of equal cost multipathing. There is only one path according to the policy you can choose. At last, we saw four message types we have in BGP. One is open, another one is keep alive, another one is update, another one is notification. Difference between update and notification is update is the advertisement of network and the attribute. Notification is error, neighbor failed, neighbor dead, something like that. Sometimes link failed, something like that. All error related things are notification. Open message is the very first message after three-way handshake where a router introduces itself to its neighbor with its router ID. You say, hey, I'm coming from this autonomous system and my router ID is this. That's what open message is. Keep alive messages are like a ping message which are sent every 60 seconds to maintain the neighbor. Right? Because this is the protocol of internet, you need a unique ID to be identified in the internet. So the autonomous system numbers are not you reusing it randomly. Your upstream ISP will provide you. In my case here in lab, I have no issues. No one is going to file a case against me if I use this autonomous system 1000 and 2000. So as usual, we will form neighbor and then we will ping between this loopback. Let's use a notepad to to the basic config. See, like OSPF, BGP will also use the loopback address. Loopback interface address is the router ID. I put 252 to loopback. It cannot be. It can be 255. It can be anything, but usually loopbacks we fully mask. All right. Next. I hope you all comfortable with this configuration. Just IP address. Next. This is going to be two. All right. So we got the IP address. See, very important is your neighbor should be pingable. Otherwise, you cannot form neighbor. Why? This is not going to discover a neighbor using multicast. This is going to do three-way handshake. If it is not reachable, how it will form three-way handshake? You see, on R1, I'm going to say neighbor as 100.1.2.2, which I should ping first. If only reachability is there, the neighborship you can think about. Okay, if there is no reachability, you cannot think about neighborship. Like as you see from here, I'm pinging. See? So, very important. You need to have reachability. Okay, here we go. I'm going to sniff the Wireshark using Wireshark, the packets. And now, as of now, there is only CDP updates going on. The Cisco Discovery Protocol, it will be sending updates saying, I'm this platform, I'm talking from this port, and this is the address. See, 10.00. This is router 1 sending this information. Duplex, full duplex, all the stuff. Capability, I'm a router, This is not important now. That's CDP, Cisco Discovery. You don't see any other important messages here. And these are all only layer 2 conversations. When I go and ping, then you may see ICMP. See, it will come. Not just ping. You see ICMP. Otherwise, there is no layer 3 communication. Only layer 2. Now you see, the moment I put BGP, you see what happens. I hope you are all ready. I'm in router 1. Router BGP. According to what we have discussed, this router will be in BGP Autonomous System 1000. If you want, I can show you the pictures. 1000. Autonomous System 1000. And neighbor is in 2000. 100.122 is the neighbor address. Neighbor is in 2000. Okay, I say neighbor is 100.1.2.2. See what command I'm using, not network command. For this long, we never used this command in any protocol. Maybe in OSPF you might have used in NBMA to manually configure neighbor. Usually, routing protocols will discover neighbor dynamically. Usually, normally, generally. But here, this is a TCP based protocol. You have to mention the neighbor using the neighbor command and also to the autonomous system which the neighbor belong. Neighbor belong to 2000. So we have to mention that. Listen, router 1 belong to 1000. In router 1, you are giving the IP address of router 2 as a neighbor. And also you are telling what autonomous system that neighbor is in. As soon as I hit enter, see the Wireshark right now, it is very calm and quiet. Very calm and quiet. No layer 3, nothing. But the moment I hit enter, see what happens now. Aha, it started. You see, this is router 1 address sending packet to router 2, and it is TCP packet, and you see the port number 179. Let me click that. When I click, you can see the packet is going from router 1 to router 2. And it is sending with a TTL1, we'll talk about that later. It is sending to this destination address with a port number. The source port number is a random port number, but the destination port number is 179 because it is BGP. But the problem is this is not a complete conversation. Why? The three-way handshake is not successful. You see, listen closely. It's a SYN packet, synchronization packet set. Okay. And packet coming from router 2, see, this is coming from where? Router 2 to router 1. It is not a SYN-ACK. Instead, it is a reset ACK. What is that reset? Router 2 is not ready. Router 1 is ready. Router 1 is sending SYN. Router 2 is still not configured, so router 2 is not accepting. Instead, router 2 is saying, I'm not ready. Router 1 is saying very politely, let's form a neighbor. Router 2 says, அதெல்லாம் முடியாது போ. No, it's not possible for me. Again, router 1 is trying. Again, router 2 is saying, no, not possible. Not possible. That is what resetting. The three-way handshake is not getting completed. Only when you finish configuring router 2 with correct IP address of router 1, three-way handshake will complete. After three-way handshake, open message will be sent. After open message, open confirm, after that only the keep alive updates you can see. Now, let us go to router 2. Meanwhile, I also, before going to router 2, I also want to show you those three tables. Number 1, show IP OSPF, sorry, show IP BGP neighbor. I told you this command we will not use much. Many people don't like to use because of this issue. It will show you pages of information. The neighbor is still idle only. Neighbor has not come. So neighbor router ID is unknown. It's all zero, no packet sent, no packet received. Instead, what we do is we use this command, show IP BGP summary command. This is the best command to see the neighbor. It says, yeah, this is a neighbor configured, but the neighbor never come. The neighbor never come up. The neighbor is in autonomous system 2000. Ketigala. We are in autonomous system 1. That neighbor is in autonomous system 2000. Our router ID is 1.1.1.1. That neighbor never come up. Patigala. Never, never. Okay. See how nice this command is. Show IP BGP summary. Now, what is the other command? Show IP BGP command. This will show what all network we advertise and what all network neighbor advertise. As of now, we did not advertise anything. Neighbor is also not present. Neighbor never come up. So the table is empty. Obviously, the routing table will also will not show anything under BGP. Okay, let's go to router 2. Behind, I would like to run this Wireshark. Router BGP 2000. This is the autonomous system number of router 2. And the neighbor of that router 1 is 100.1.2.1. You can also see in the Wireshark. You need to put the correct address of router 1. See, router 1 is sending with that address. You need to put that exact same address which router 1 is using to talk to this router. And neighbor, remote AS 1000. Please pay attention. The moment I hit enter, a three-way handshake should happen first. That reset, reset. You should not see that reset comma acknowledgement. RST means what? Reset. Instead, you should say sin comma ack. I hit enter. See at the background, it will come now. Mada mada gada gada என்று வரும். வந்துடுச்சு. Now let us see here. Go back to router 1 and type this command show IP BGP neighbor, which we don't use much, but I'm just showing you. It says neighbor status established. Neighbors router ID is this. This is the router ID of router 2. So far, how many packets have been sent and received, all the stuff it shows. But the best command I told you to use is show IP BGP summary. You see, neighbor is up for last 36 seconds. So far, 4 message sent, 4 message received. But no updates learned. Prefix received is none. We did not advertise anything, so nothing can be learned. So you need to advertise from R2. Only then you will see some number here. Otherwise, it is 0. 0 says that I'm just a neighbor. That neighbor did not give me anything. That's the meaning of this. Neighbor did not give me anything. But we are already neighbor. We are up. Neighbor is up for last 1 minute 23 seconds. So because we did not advertise, we will not learn in BGP table, nothing, neither in routing table. We are just a neighbor, a step. Right? Now let us also check here. Show IPBGP summary. This also says I'm neighbor with this guy who is in autonomous system this for 1 minute and 53 seconds. He also did not give me anything. I also don't give. He also didn't give. I also didn't give. Okay, now let's go back to the Wireshark story. Go up. You see, three-way handshake. First handshake going from 1 to 2. Second handshake is CNAC going from 2 to 1. Third handshake is going from 1 to 2 again. Okay, this is what called as three-way handshake. CNAC, ACK. And then you see open message is sent by router 1 to 2 and router 2 to router 1. And then keep alives are sent. And then updates are sent. In the update, actually, there will not be anything. We did not advertise anything. Update, there will be no information to carry. See BGP protocol update. Nothing, you don't see anything. After that, if you see, there are a lot of keep alive sent every now and then. Keep alives are sent every 60 seconds. Both the routers will send keep alives. So neighbor is established. Now what I'm going to do, I'm going to advertise a network. From R2, I'm going to advertise the loopback. Listen, listen, listen. Router BGP 2000. I have a loopback here, 2222, so I'm advertising the network 2.2.2.2. You have to type this word mask. In another protocol, we don't type this word mask and all. In BGP, you should type the mask if it is not a classful. If it is classful, you don't need to type. If it is not a classful, then you need to type and then say the mask. It is not a wildcard mask. You have to type subnet mask only. Now, if you go back, you will see an update. Look at this. As soon as I hit the enter there, you got an update. Who is sending the update? Router 2 is sending an update to router 1. Now, I would like to show you that update. It will carry that what I advertised. See, it is saying network layer reachability information, meaning it is sending a network called 222 with the mask that I prescribed 32. And along with that, it also advertises these attributes. BGP updates are too heavy, you see, that's why you should use BGP only if it is necessary. It is not only advertising a network, for each network it is saying this is the origin attribute, this is the AS path attribute, this is the next hop attribute, this is the multi-exit discriminator attribute. Too much, you see. Now if you go to router 1 and check this command show IPBGP summary, you see one prefix learned. Last time when I was checking, I saw one motai. I saw one 0 there. But now I see one, meaning one prefix, one network learned from this neighbor. Who is this neighbor? Router 2. Router 2 is in which a autonomous system 2000. Now, if I type show IPBGP command, I can see that network coming from the next stop router 2's address, coming from the AS number 2000. See, it's a path vector protocol. It shows the autonomous system path. It says to go to this 22222 network, your next stop is 100.1.2.2 and AS path is 2000. Meaning that's the autonomous system. All right, now if I try pinging from R1 to 2.2.2.2, I'll be able to ping because there is a route in the routing table given by BGP. See the administrative distance for eBGP. Yeah, there are two BGPs, okay? eBGP, IBGP. External Border Gateway Protocol, Internal Border Gateway. This one, what we have done is External Border Gateway Protocol. More about this is coming in the next chapter. All right, so 2.2.2.2 is learned through eBGP. So administrative distance of eBGP is 20. Administrative distance of IBGP is 200. Remember, though we are going to learn in next class, I'm writing down here eBGP administrative distance is 20. What is eBGP? What is IBGP? If you know, good. If you don't know, don't worry. It is coming later in the next chapter. IBGP is interior in border gateway protocol, external border gateway protocol. This is 200. This is 20. Basically, eBGP is two router in two different autonomous systems. Like we have 1000, we have 2000. Forming neighbor between them is eBGP. If you have another router here, and if you form neighbor between these two, it is called IBGP. IBGP is 200. More about this is coming later. All right. As of now, whatever we have learned, we have also seen more than that. I'll